Good morning, good evening, everyone, or afternoon. Thank you all for joining us live or on demand. We hope you're all having a great week. My name is Brandon Ruiz, Product Marketing Manager here at EMQ. And today I'm happy to be joined by Jim Fan, VP of Product, and Chait Diwadkar, Director of Solutions Engineering over at TDengine. And today we're really excited to talk to you about real-time IIoT data ingestion, visualization, and using the EMQX platform and TDengine conjoined together. So today we're going to dive into the critical role that real-time data plays in IIoT and really how reliable, low latency ingestion and visualization can transform your operations across different industries, right? Particularly in manufacturing Industry 4.0. Jim and I will start with a quick overview of how EMQX and TDengine fit into this picture. And this is really going to set the stage for the live demo we have lined up. And in the demo, Chait will guide us through an end-to-end solution where we'll use MQTT for testing, EMQX dedicated for reliable data streaming, and TDengine for efficient data storage, and Grafana for the visualization layer. And you'll see exactly how our technologies work together to deliver a seamless IoT data experience. And before we dive in, just a quick note on housekeeping. The session will run for about an hour, and we'll start with these brief introductions, EMQ and TDengine, and we'll follow that with a live demo, and we'll wrap up with a Q&A the last 15 minutes of the session today. So if you have any questions along the way, please drop them in the chat, and we'll address them at the end. So, oh, and one last thing too, right before the Q&A, we will initiate a poll as well. And your participation would be very appreciated there. What it does is going to tell us how the session today was for you, how it was received, and how we can ultimately tailor and refine these going forward, right? So it's at the end of the day to make this experience that much better going forward. So with that, let's go ahead and get started. So before diving into what it is that EMQ X is, which is very robust and scalable MQTT broker, wanted to do a quick introduction of what MQTT is as a whole. So very high level, right? We do have deep dive materials on this, but this will just be a quick glance over. It was created in the 90s by members of the IBM team. So Andy Stanford Clark, Arla Nipper, and it was originally designed for oil SCADA systems. So in rural areas that are hard to come by connectivity, and it was a publish subscribe model as illustrated here, right? So you could have devices publishing information to the broker, and then you have different endpoints subscribing to these information points to be able to get that data. So instead of having that continuous constant connection where you have constant push and pull of data, the broker is now going to manage that exchange of information, right? So another thing that's great about MQTT is that it's very low bandwidth. So again, if it's strong in areas where connectivity is hard to come by, so rural areas, very congested networks like a manufacturing floor or smart cities, or even transient use cases like vehicles, right? EVs that are on the road that are network switching. This is another good solution for that. And as far as efficiency goes, has a low power draw, so it can also be used for small devices that are run by battery, that you would see like in hospital facilities and such. Another thing that stands out about MQTT is its reliability to ensure that messages are sent from point A to point B. And there's a number of mechanisms that help do that. There's quality of service, tiers 0, 1, and 2, standing for, at most once, at least once, and only once. Exactly once, rather. There's also a last will and testament, so you can set rules similar like you would in a will in real life. If there's an unexpected event that occurs, you can set logic to occur in the event of those happenings, right? So there's that, and there's also a keep alive mechanism that is a cadence check-in to say every 30 seconds we want to check the connectivity, or every day, whatever the cadence is, to make sure that your system is up and running at all times. And another point, as it pertains to the manufacturing world, reporting by exception is very important, right? So being able to only transmit data when there's a status change whether you're talking about temperature or pressure, that's really going to help cut back on overhead and your overall cloud costs. So if you see temperature change by 5 degrees or pressure by 5 pounds, right, you could set those parameters. But another great value point there. So now that you have kind of a quick understanding of what MQTT is, I wanted to really explore, the EMQX platform as a whole and look at some of the key strengths. By no means are these all of them, right? Just ones I wanted to focus on today. So starting with all-in-one connectivity. So our platform really connects diverse devices, supporting different protocols, right? So it doesn't matter. It can support up to 100 different protocols across new and old devices and convert those into MQTT, right? So it helps unify your ecosystem of devices. Uh, with regard to enterprise grade performance, it's really for high demand environments, right? So you can handle up to 1 million messages per second with sub-millisecond latency and up to 100 million connections per cluster, which we have benchmarked, and we do have a customer that's proving that today. So high connection rates, which are higher than most folks need, but we thought it was important to get those thresholds in there. And last but not least, wanted to talk about the flexible data integrations. So out of the box, we have 40 integrations that allow for easy connectivity with things like databases, analytics tools, AI platforms, and more, just like with TDengine. And this flexibility really helps you build those real-time data pipelines that support various workflows and data destinations with that minimal setup, right? So together, these features make EMQX a powerful solution that allows you to scale for your choice of enterprises, and it helps you with speed, reliability, and adaptability. So now that I gave you kind of a crash course on our platform offering and what our core tenets are there, wanted to be able to speak to our different deployment options here, right? So starting with serverless, it's deployed on a public cloud with multi-tenant structure. It's ideal for prototyping and smaller projects. It does have a pay-as-you-go with auto-scaling capability, and it really allows businesses to grow seamlessly without the burden of managing resources, right? So it's really perfect for those early stage IoT initiatives. And then for dedicated, this is exclusively deployed on public cloud infrastructures, and it offers each customer with its own isolated environment, like a VPC, and for that enhanced security and performance. And it's built for those larger IoT scale projects, a step up from serverless, and it gives you that high reliability and scalability with that uninterrupted access. And then you have BYOC, which is bring your own cloud, right? And this option really enables our customers to deploy EMQX within their own selected cloud environment. So it doesn't matter if it's AWS, GCP, Azure. It's going to be initiated within their own stack, and it's going to use it's really good for those more data privacy concerns that you have that have more stringent requirements, things like medical, where you have HIPAA. You don't want to have any data shaking and changing hands. And then Premium was our most recent release within our cloud package that we have. And it's important to note the way that we've segmented this here. The 4 offerings on the left are the fully managed cloud offerings, and then on the right, self-managed enterprise for those large scale deployments that you're managing yourself. So think of Premium as an enhanced version of dedicated, and it really adds those enterprise grade features like things like dedicated storage, cluster linking, dedicated account management, and it lets you personalize support for your data operations. And then for enterprise, the most flexible option, I would say, can be deployed on any cloud environment, public, private, hybrid, or even on premises. So it's really tailored for organizations that have, again, strict compliance requirements. With this option, you get access to 24/7 support. You have the option to do 8 hours, 5 days a week as well. But would say that this is the highest level of customization and control, which we see is a strong choice for customers that are doing deployments in Industry 4.0 in manufacturing. So All of these offerings will help in that message of unifying your stack, and it aligns best with your operational needs and scale, depending on, no matter what size of the business you're currently at. We have a solution to get your foot in the door, to get you experienced, and to be able to grow as we go here. The next offering I wanted to speak to or introduce real quick was NeuronEX, which is our industrial edge gateway. This solution is just like our others, is strictly software, but it can be deployed on something as simple as a Raspberry Pi at the edge. And the real value here is it's helping you bridge the gap between IT and OT systems. And it helps you think of it as an edge translator that takes in over 100 different protocols, converts those into MQTT, and then passes it to the broker. It's also equipped with a rules engine at the edge, so you can do some compute there before sending it out. Again, saving you on more cloud compute. And then below there are some examples of some popular protocols: Modbus, OPC UA, Sparkplug-B, right? Those are all protocols that we work with today. And if your device has enough headroom on it, it can even be deployed on devices you have locally there, right? But the main value is you're able to unify different protocols as well as products that are made of different ages, right? So mixing both greenfield and brownfield together, which is becoming more and more important in the space. So I've given you a high-level overview of kind of how our platform is architected from the edge to the cloud. This is more of a detailed view showing you the transmission of data throughout the process. So from edge, you're connecting it, the different protocols are then routed, processed through the rules engine, and then from there, you're able to plug into backend systems, data bridges. And as I mentioned before, you can see that the deployment options are very, they're various. So you can do on-prem, public, private, containers like Docker and Kubernetes. And then with regard to management and monitoring, with our own environment, that gives you kind of the vitals of your broker's health, right? It's not visualization like a Grafana or Snowflake or Datadog. That's in a backend process, but that is what you'll get from that component here. And then how does this all tie in together at a high level? I wanted to introduce a concept, unified namespace, or UNS. It's a concept that's been around for quite a while, but is recently coined by Walker Reynolds and his team. So it's gaining a lot of traction. And so with our offerings here, as you can see, EMQX Platform and NeuronEX, where does that fit into this concept, right? And simply put, instead of doing something like a ISA 195 point-to-point connection, where if you wanted to make upgrades in that model, there was a lot of risk for potential downtime because there was dependencies on different connections, right? It was like a mishmash of connection points. So instead of having the dependencies between things like SCADA, CNCs, PLCs, all to each other, now those are going to a factory UNS, which it then goes to a company UNS, right? So you'll have one single access point instead of different dashboards for different lines, areas, sites. What we're trying to do here is give you a hierarchical view to drill down into different areas within your instance, right? So think of EMQX as the router of information processing that will then attach to a dashboard like a Grafana, which we'll see in a little bit. And then everyone from all sides of the business, whether IT, OT, or otherwise, will be able to access, given their role-based control, to see different data points. So with that, that's my quick introduction that I have, and I'm happy to pass things over to Jim to take you through TDengine.
Cool. Thank you, Brandon, for the introduction. Hi, everyone. My name is Jim. I'm the VP of Product for TDengine. My main background is manufacturing, industrial IoT, and time series database. So both my colleague Chade and I were, like Brandon, we're all based in the San Francisco Bay Area. So today I'll take you through a few slides, give you a quick intro for TDengine. So TDengine is high performance, very scalable time series database designed for industrial IoT. We have customers across different industries, but our main focus is towards the manufacturing, industrial IoT, and energy space. So a very quick overview for the company. We were founded in 2017 We are an open source software company. Our open source version has been downloaded by more than 600,000 people around the world across 50 countries up to this point. And on the commercial side, we have over 200 paid customers, mainly in the energy, utilities, and manufacturing space. We also have quite a few customers in the automobile spaces, mainly using that for connected vehicles. We have offices in North America and Asia, and right now we have over 100 employees and over 60 full-time developers. Here's the overall sort of ecosystem for TDengine. As you can see, on the data ingestion side, we support a number of industrial protocols like OPC UA, OPC DA, and MQTT, so we can connect seamlessly with an MQTT broker like EMQX. We also support getting data directly from other data platform like a data historian like PySystem, Wonderware, or if you have data in Oracle or MongoDB, we can help you import these data directly into TDengine. And when you're loading these data into TDengine, we support ETL. So you can do data cleaning and data filtering as you are loading these data into the TDengine, the database itself. And when the data is in TDengine, we support all the major cloud platforms. So we support AWS, Azure, GCP. We also have on-premise configuration. And when the data is in TDengine, you can connect that with a number of analytical or visualization tools like Power BI, Tableau, Grafana, or Seek. Since we support ODBC and JDBC connectors, so any tool that's compatible with those standards can connect seamlessly with TDengine. And also you can share your data very easily with your partners, your clients through what we call data subscription. So it's a pub-sub mechanism. You can very easily share your data, maybe the entire database, maybe just a portion of the database, or maybe just a few columns of the database to anyone that you want to. So later in the demo, Chait will give you a brief intro of how we are getting the data from an MQTT broker like EMQX. So data in this process will be demonstrated later in the live demo by Chait. Chait will also show you how we're connecting with a visualization tool like Grafana once the data is inside TDengine. So on the architecture side, this is a very typical use case of many of our customers in the energy and manufacturing space of what we call edge cloud synchronization. Since TDengine is extremely efficient, you can even install TDengine on something like a Raspberry Pi. So we're very efficient. A lot of our users, when they have sites that have very spotty internet, they would usually install a TDengine on the edge to constantly get data or consolidate data onto their edge instance. And when the internet is back on, we have a feature called real-time replication. So it's essentially a real-time replication that enable you to do edge cloud synchronization. And for the sites where there's a very consistent internet connection, you can simply use MQTT to get all your data to the cloud. Using the same function, you can also do data replication or data backup in a separate location using the same replication feature. So that's a very typical sort of edge cloud architecture that many of our larger customers use or deploy. On the performance side, so this is a industry standard benchmarking tool that it's not designed by TDengine. It's an industry standard benchmarking tool that every time series database companies use to compare the performance with each other. And as you can see on the left-hand side, it's the query performance. So the blue curve represents, the blue column represents TDengine, and the orange and red one represents the two other major players on the market. And this is the average response time of 5,000 queries over 4,000 devices. And as you can see, we're up to 30 times faster than our major competitors. On the data ingestion side, we're also up to 10 times faster than other major players on the market. We also have very efficient data storage. So we support up to 10:1 compression ratio or even better, depending on the pattern of your data. And the reason that we have a higher compression ratio than our major competitors is that on top of the two-stage compression mechanism, that many databases use. We also have a very unique design, which is called one table per device. So what that means is essentially if you have, let's say 10,000 or 100,000 IoT devices, for each device, we have a dedicated table for that. And the reason is that usually for all the time series database algorithms, we deploy some kind of delta or delta of delta encoding during the compression process, which means we don't save all the data in one column. We only save the first number. And for the second one, we only save the delta. For example, the first number is, if it's voltage, if it's 220 volt, and the second one is 221 volt, we only save that one, the delta, which is 1 volt, in our database so as to compress the data. So the smaller variation you have within one table, the better compression ratio you have. And usually we find out that for data coming from multiple devices, if we're putting that into one table, usually they have higher variation, much higher variation than if we have one dedicated table for just one device. And that's how we're able to achieve an even higher compression ratio compared to other time series database on the market. So on top of these two, we also support tier storage, which means you can save, we can help you automatically move some of the colder data, the data that you don't use very often, to a cheaper storage like an HDD, from SSD into HDD. And when you're doing the query, the user experience is the same. You don't have to worry about where the data is. We will automatically locate these data for you. So from a query perspective, it's exactly the same. But at the same time, we help you move all those colder data to a cheaper storage in the backstage to help you save storage costs, essentially. So a high compression ratio in combination with the tier storage, that's how like our users can save really a ton of cost on the data storage itself. A few case studies. This is a case study a customer we have in the renewable space. It's a pretty large customer of ours. In total, they have about 40 gigawatts of renewable generation operation in total, spanning across wind turbines, energy storage, and also solar plants. And overall, they have 300 sites. What they do is that they consolidate all the data into TDengine. And once the data is in TDengine, they will build all kinds of applications like visualization, dashboards, or doing AI data analytics on top of that. And in general, they have about 800 terabytes to 1 petabyte of data per year. So it's a pretty large deployment and operation for the amount of data they're collecting. And TDengine proved to be extremely scalable and highly performant according to what they need or according to their requirements. This is a smaller, so we work with companies of all sizes. This is a smaller customer based in San Francisco. They manufacture solar trackers. So before TDengine, they were using another database. It's a NoSQL database, but that database was not able to perform acceptably as they were scaling their operation on the business side. So before deploying TDengine, they really had that data pipeline issue with the other database. On top of that, this DynamoDB, they don't support SQL query, and that's another thing that we support. We support standard SQL query during the query process. So that's why they were choosing TDengine as an alternative or as a replacement for their previous database. And their configuration is also very simple. So directly from the site, they will import or they will get all the data into TDengine directly through MQTT. And once the data is in TDengine, they will build their dashboards, build their analytics on top of that, even the alert system. So in case anything goes wrong, there will be an alert system that tells the maintenance guy something needs to be fixed or something needs to be cleaned, for example. Here's another industrial use case with Siemens. So in this particular case, I want to showcase a comprehensive feature that we have with TDengine. So besides, this is a before architecture. So before using TDengine, Siemens and their IoT product, essentially they're using Kafka for streaming as a streaming tool, and they're using Flink as a stream processing tool. And they're also using Redis to save all the recent data. And on the historical data and aggregated data, they were using PostgreSQL. So this is the before architecture. As you can see, there are many individual elements. And one complaint from Siemens is that there's, their clients, they have to have dedicated servers for each individual elements. So one benefit for TDengine is that we have all these features included inside our platform, which means we do have streaming function, we have stream processing, we also have embedded caching capabilities. So for companies who don't want to use a dedicated stream processing tool or individual sort of a Kafka, they can simply use TDengine. And that is a mechanism that drastically streamlines the process for many of our users and makes their life much easier. And on top of that, after deploying TDengine or integrating TDengine, after streamlining the whole process, Siemens was able to achieve what they call the P99 latency, which means for 99% of their query, they were able to perform those under 100 milliseconds. So that's something that was also very impressive. They were happy with using TDengine for. On the deployment side, we support both the fully managed cloud service, the TDengine Cloud, and we also have on-premise configuration. So we have a lot of clients in using both deployments in different occasions and different industries. And on the data security side, we're fully SOC 2 certified in the US, and in Europe, we're working with major manufacturers. So we're also ISO 27001 certified. So that's the final thing I'm going to touch on before I pass it over to Chait. So Chait will walk you through live demo to show you the whole process from data in all the way to data visualization with Grafana. So I'm going to stop sharing at this point.
All right.
Cool.
So I'm going to walk you through the process of setting up EMQX, setting up TDengine, and then also visualizing the data in Grafana or any other visualization system. The first step, of course, is to set up your EMQX instance. In our case, we have a dedicated instance, as you can see here. And we have set it up in a fairly normal way. You can set up SSL, of course, which is really convenient. There's VPC peering as well. And you can do load balancing and you can set up a NAT gateway and so on. So all of these features are extremely useful and they're actually very simple and well documented on the EMQX side. So I'm not going to go into detail over there. In terms of access control, I did set up authentication over here. And also I do have the authorization for the username over here. And again, all of this is very well documented in EMQX. And there's also a nice convenient blacklist. These are all the default ones that come with the EMQX platform. So that kind of helps in keeping things secure and running. They also have really good monitoring. So you can, of course, get really good metrics about what's happening here and a really nice timeline over how things have been connecting and subscriptions. And you can also see the current client connections that are active. So just to give you an idea, these 5 are the simulators that we have running. We are basically simulating 5 chemical plants. Each chemical plant has 10 reactors, and these 10 reactors are sending data to the EMQX dedicated instance that we have running here. And then this client up here is actually our TDengine instance, which is running in TDengine Cloud on AWS. And that's connecting to the broker as well. And that's where it's ingesting data from. And this is the MQTT client, which is a really nice tool that EMQX provides that you can use for testing your clients and testing the messages that are coming from each client, and then also making sure that you can subscribe to the topic and get the right messages from the topic and so on. Okay. So let me actually show you now what MQTT looks like. So you can see that I'm connecting to that instance. And this is the topic that we're publishing all of our data on. And you can see we're constantly getting new messages over here. And you can see the content of the message here, which is really convenient, right? So I'm getting, this is the batch ID. So now I know that this is the Springfield plant. It's React to 9. And I can get an idea of what time the batch was started. It was about 11:14 a.m. And then you can kind of get a sense for what parameters are being sent by the reactor, right? And of course, you can also choose to publish messages to that topic just for testing purposes and see if you're receiving that message at the clients and so on, okay? And that's over here in the publish. I haven't published any message here, but I could very easily. So this is a really nice tool that you can use to connect to any MQTT broker actually, and test your messages. And obviously, it doesn't have to be JSON. It could be any of these. The payload could be any of these formats, right? So it's a very convenient tool. Now let me switch over to TDengine Cloud. And this is where we've set up the database. And this is our super table. And a super table in the TDengine schema uh, is basically a table that is made for a particular type of device. So since these are all reactors, I bunch all of them under the reactors or the all reactors super table. And let me show you what that looks like here. So you can see that I have two tags, plant ID and reactor ID, and then the actual data that's coming in. And then you can see that I can take a look at this hierarchy, right? So for example, I know that in the Fremont plant, there are 10 reactors, and then you can see the reactor names, and you can now go in there and and then look at the data as well that's coming into this, okay? So this is a simple, quick way of looking at what's going on inside the database, but you can also run you can also save specific queries that you want to run inside here. And as Jim mentioned in his presentation, we do support standard SQL. So as you can see, this part is in fact standard SQL. It's just a simple select. I'm just looking at the product, or sorry, the sum of the manufactured product for the last whatever number of hours. And if I run this, you can see I'm getting that data over here. We also have a very simple charting tool built in over here. So I can actually now graph this. And this is one way that you can test your queries before you use them in an analytics tool like um, Tableau or any other analytics tool. Or if you want to now put this query into Grafana, for example, to do any sort of visualization. Now the question is, how was all this set up? How did we set up this database to ingest data from MQTT and from our EMQX instance? So that's done over here in our data sources. So let me show you how a data source is typically set up. You just give it a task name. This is our list of connectors. As you can see, we do connect to a wide variety of sources, including MQTT, but we do support relational databases similar to the way that EMQX does. We do support other historians as well, InfluxDB, OPC UA, which is a very standard protocol. But let me show you what the MQTT looks like. You will see that we do have this concept of an agent. So in the event that the EMQX instance was in your own private cloud, this is something that Brandon mentioned, of course, where he calls it bring your own cloud. If that was the case, you may need to install an agent because there may be a firewall in between your own MQTT instance, EMQX instance, behind the firewall in your own cloud and TDengine. So in that case, you would need to install an agent, and the agent is just a small, simple piece of software. All it does is it sets up a connection with the EMQX instance, and then it sets up an SSL connection with a TDengine instance. And as with EMQX, you can also bring TDengine into your own cloud as well. So if it were your own cloud TDengine instance, again, it would make no difference. It would still be an SSL connection with your own enterprise TDengine version. Okay, so you would select, once you've done that, you would select the target database, you would set up your host and port. authentication. You could, of course, enable SSL as well, and then set up your topic or topics over here, check the connection. And once you set up the connection, you can actually now connect to that server, get some messages in here, whatever the payload may be, whether it's JSON or plain text or whatever. And then you can parse it. And I'll show you how that's parsed in a second. And then you can also do extractions, filtering, and then map that to a super table. And the nice thing is that with our MQTT connector, we actually give you a schema in your super table. You're of course welcome to modify it, but our schemas are fairly well optimized for the way for the messages that you're getting. And now let me show you, and that's pretty much it. Once you've done that, you can click out over here and then get going. But let me show you what our current connection to the EMQX instance looks like. So you can see this is our target database. We don't have an agent in this case because we actually have a direct SSL connection to the EMQX instance. This is the MQTT host. I'm on port 1883 because this is not over SSL. I have not enabled SSL. I do have authentication, however. I chose MQTT protocol version 3.1, but you could choose, we do, of course, support the 5.0 version as well. And this is our topic. I'm just choosing QoS 0. Then we can check our connection. And then once I've done that, here's the messages, few messages that I'm getting from the EMQX instance. And then I've parsed that, and you can see the result of the parsing over here. Okay. So we are mapping it, and now I can map it to the columns in the database as well. So, and once that's done, you click save and apply in this case, or save, and then we're off and running basically. So if I go back to the data sources and I view over here, you can now get a sense of how long this has been running, how many inserts we've done over the past since it's been running, and also the accumulated data that we have from the EMQX instance. Okay, and so that's how you set up the actual connection, what we call our data source or data in. And this is our Explorer where you can now look at the data. And as I mentioned before, you can look at it by the plants. This is a good way of viewing the hierarchy. So one thing you will notice that in the TDengine schema, we do preserve the hierarchy, we do preserve the context and using different kinds of tags. And you can have much deeper hierarchies as well, right? You can have, right now I just have plants in the US, but you could have plants in Europe and have those in the hierarchy with the country as a tag or the continent as a tag or whatever business grouping you have within your enterprise as a tag. Okay. In terms of some of the APIs that we support, we're very versatile. We try to support developers as well as we can. So you can see that we do support Java, Python, Node, C Sharp. We do support C and C++, even though that's not mentioned over here. And we do have an ODBC driver. And we do actually also have a JDBC driver, which I'll get to in a second. If you click on any of these, this actually gives you the exact connection tokens that you need to connect to this particular instance. And as you can see, we do support REST and WebSocket for Python. We show you how to integrate that into Jupyter. And then, of course, we're an open source database as well. So we do have extensive documentation, both on our documentation and our website, as well as on GitHub. Okay. In terms of the tools, we do have a command line interface. So if you're used to Oracle or Postgres SQL, we do have a CLI, a shell that's very similar to those. We do support Grafana. That's what I'll be showing you in a second. But again, if you click on any of these tools, this walks you through the exact steps that you need to connect to your instance. So you never have to think about, I know how to connect to generic instances, but how do I connect to my particular instance? That's all in here. Okay. Similarly, we do connect to Power BI. Power BI is supported through our ODBC driver. And again, if you click on the Power BI card over here, this tells you exactly how to connect and then how to start looking at data in Power BI. Seek is something that's used a lot in industrial manufacturing. And so we do support that using our JDBC driver. Okay. So now let me go to Grafana and show you how we're visualizing the data that's in this database. Okay. Um, so you can see that we're looking at some real-time data over here and then looking at some production data in the past 12 hours over here. And this is a great way of visualizing what's going on in real time. So you can see that there's something going wrong here. I'm looking at data here for the last 1 hour. And so you can see that it's pretty nice. You can kind of tell that something went wrong in Kalamazoo 3 production in the last 1 hour. And then, you can drill down and look at what's going on, right? But if I look at what's going on behind the scenes over here, it's a very simple query. It's just simple SQL, right? And this is our plugin that we've built for Grafana. And we do support all the different visualization types in Grafana as well. And we do support different, having multiple queries in the same panel and so on. So again, this is a very powerful, simple way. If you're looking to do some quick prototyping and you have EMQX and you have MQTT clients on your machinery, you can develop a very quick prototype using a combination of EMQX, the TDengine connector for EMQX and MQTT in general, and then visualizing all that data in Grafana. To set up all of this, other than the simulator, which I wrote from scratch, but if you have actual industrial machinery, you have an MQTT broker like EMQX, and you have TDengine and Grafana, you can start visualizing data from machinery in just about a day using just very quick prototyping methods. And we do have some videos and blogs on the TDengine website that will guide you through how you can do this quick prototyping and start getting data from MQTT into TDengine and then visualizing that in Grafana. I'll stop here and then we can now move over to taking questions.
Yeah, thank you very much for that detailed demo and overview. Hopefully, it was very informative for everyone attending today. One thing I did want to touch on before, I accidentally skipped over it. With regard to privacy and certifications, wanted to lead with that. This is something that is purpose-built into our platform. We take it very seriously. And over time, making sure that we have the latest requirements, certifications to make you feel good about working with our technologies with us. And this is not an exhaustive list, right? But if you want to click a closer look, do encourage you to take a look at our Security and Trust Center. This can be found at the footer of our website. So please do take a look, and we will continue to update this over time. This is a never-ending battle here.